Average cost, yeah. That's the key. That's what we're going to, we have some problems that say maximize. I was doing some problems with the Calc 1 classes today, and they're doing exactly the same thing. Again, you're studying almost the same thing each day, but for them, we had a problem of taking a circle and putting an isosceles triangle in it, and what maximize the area of the triangle? What size, what's the height on the triangle that maximizes the area of that? There's a little different approach to that, but we also had to key in on the fact that we were maximizing the area. So we had to have an area function. Here, you want to minimize average cost, so you have to have an average cost function. It's all the same thing. You might have different problems, but you could study with the Calc 1 students very easily because we're doing the same thing. So if we want to minimize this, okay, how am I going to do? What's my plan? To minimize this, I'm going to have to first do what? Yeah, determine the derivative. The derivative of what? Cost or average cost? Yeah. Now I'm going to help us out. We're going to say average cost. So AC is average cost, and it'll be AC of n. So this is the function name, AC. So we're going to have to find the derivative of average cost with respect to n. When you do that, if I keep it in this format, we're going to have to use what rule? Do you really want to use the quotient rule if you have to? I don't. So the first thing I'm going to do, let's see if I can capture some of this. There we go. The first thing I'm going to do, I'm going to rewrite my average cost function so I don't have to use the quotient rule. I have three fractions. If I break them up, if I divide each of those terms, you know how it is in arithmetic. If you have fractions with the same denominator, you can add the numerators and place it over the common denominator. Well, we're just going to do backwards on this. So we'd have 5/10 n plus 10 plus 7,200 divided by n. But another way of saying that is n to the negative 1. Now I don't have to worry about the quotient rule. I'm as happy as you are, okay? A little less work. So, 5/10 plus 0 minus 7,200 n to the negative 2. If you like, 5/10 minus 7,200 divided by n squared. Either way. I'm trying to minimize this. So now what? The function will have an extrema when what happens? Let me put it differently. The function will have a possible extrema when what happens? Yes, okay. So set it equal to 0. And then just solve the problem, right? Sounds easy enough, but when you solve this, remember you've got two terms that are subtracted, so we probably would want to start with adding 7,200 divided by n squared to both sides. Maybe multiplying both sides by n squared. Dividing both sides by, I'm going to change that. You can keep it as 5/10 if you want, but I'm going to make it 1/2 because visually I know that if I have a fraction in the denominator, divide by a fraction is the same thing as multiplying with the reciprocal. So I've got here, I've got n squared equals 14,400. N is going to be plus or minus the square root of 14,400. Do I need the negative? We're counting number of product units, right? I don't even have negative. Okay, so we use the positive of that, and I would hesitate to, I'm not going to use the approximated value, but it's kind of nice to know approximately how much. And actually, I think that comes out to be even. Check and see. According to my notes, it looks like I've got it that it comes out to be even. Katie agrees. 120, Katie? Okay. So 120 what? Units per what? Per what? Any per anything. It's I can't value per hour. I'm not sure I want that. Just units. Just units. Because we're just solving for n, aren't we? And n's number of units. Okay, I got that. This is what? It minimizes it, right? I don't know. I'm hoping it minimizes it. If it doesn't minimize it, it may possibly be maximizing costs, or maybe it's not doing either. Okay, it could be an inflection point. So it's a possible extrema. We don't know which, so what do we have to do? Okay, now the alternative to taking the second derivative is to do what? If the first derivative values on less than 120 are positive, and on the other side, the first derivative are negative, otherwise look at the sign chart. So you could do a sign chart. If I don't tell you which one, if I don't indicate you need to use the second derivative, you really could argue that your answer using the sign chart accomplished what I wanted you to, but I'll make sure that I let you know. Okay, second derivative. So let's see, my first derivative ended up here. So my second derivative, the derivative of 5/10 is 0. So for the sake of my second derivative, I'm going to go back and make that negative 7,200 to n minus 2 degree. Okay, so my second derivative then is going to be 14,400 n to the negative 3 power. So 14,400 divided by n cubed. Now, what do I need to know in order to determine if 120 minimizes cost or maximizes cost? The only thing I need to know is what? Do I really need to cube 120? What information does the second derivative tell me? If the second derivative of 120 is positive, then average cost is concave up, which means it has a minimum. If it's negative, then it's concave down, which means it has, so I don't need to know the actual value. All I need to know is it positive or negative? Or possibly 0. Is it possible that 120 could make this 0? In fact, are there any zeros of the second derivative? Any way for this fraction to have a 0 value? Absolutely no. Okay? So that tells you there's no what? If you don't have a 0, zeros imply change of what? Concavity. So if it's changing concavity, it implies that you have an inflection point. So the fact that we don't have any zeros says that we do not have any inflection points, so everywhere this function must be either concave up or concave down. Which is it? If I put a positive in there and I cube it, I get a positive. My numerator is already positive. A positive divided by a positive is positive, yeah. So we don't really have to do any actual calculations. We just have to use our common sense. It's positive. So what? Wow, there's a wonderful math on the screen. What are we trying to find? At what production level will the average cost be minimized? So this is an extrema. We found actually that it is not just an extrema, but actually, yeah, it's a minimum. Now, I hesitate to say absolute. I mean, I'm sure it is, okay? But don't paint yourself into a corner with that, okay? I'm happy to just say minimum, so we'll just do that. But yeah, and this way, if it's going to be always concave, I think we can kind of agree that it is going to be an absolute. So therefore, a production level of what? 120 units will minimize average cost. Okay. If you know 120 units will minimize average cost, I'm going to add another part to this problem. What is the actual cost? What is not the average cost, but what is the actual cost? Could you compute that then? Yeah, just put 120 into that. Okay, very good. That's a type of problem, and so we don't get into much depth compared to what you get into in the other problem, any other course. Okay, we talked about this. I showed this to you yesterday. What did we decide about this point of diminishing returns? What happens to the tangent at the point of, yeah, it changes from being above the curve or below the curve to above, or vice versa. And so there's a point in here where actually it makes that switch. Where does it make the switch? Yeah, the inflection point. Now, I don't have that at the angle it should be, but it actually would be there. Okay. Identify the point of diminishing returns. What do we have to do? Let's plan it out here. I want to find that the point of diminishing returns is found using what? Not using the extrema, second derivative. Yeah. So in order to get to the second, we have to first do first. Okay. So we'll have to take the first derivative, and then we have to take the second derivative. Now, I would insert in here a 1.5 step, okay? And I would set this equal, I would find those zeros just in case, okay? Just in case we end up with a 0 of the first derivative as a 0 of the second derivative. Okay, just in case. And if we do, we really have to go back and look at that as a sign chart and see. And then our third step would be to set the second derivative equal to 0. Okay, there's your plan. Do we really need to go through this problem? It's just like all the others, isn't it? Good. It's just like, you'd have to, in fact, it's really not that difficult a problem because you've got just a simple polynomial here. So the first derivative is going to be, what do you agree, 1200 x squared minus 3x squared. Okay. I set it equal to 0. I would factor out, oops, it wouldn't be an x squared here, it would be an x. I'd factor out, let's say, a 3x, and I'd have 400 minus x. Can you tell me what the zeros are?